Bon dia, soc l'Oli i avui vaig a parlar de la meva tesis que trata d'una proteïna que em diu macro-H2A. That is about where my comfort zone of Catalan comes to an end, and I'm going to carry on in English, and I promise I'm still learning. I've been living now in Catalonia for about 3.5 years, and I love it here, and I can never imagine leaving. I originally came here to do my PhD in Badalona in the Institut Josep Carreras, and that PhD is kind of coming to an end, but I'd like to share with you some of the work we've done, and I'd like to show you this via a picture of some Castellers I took last year in Clot. I find this really, really cool and really interesting that these towers can be built without collapsing. And it actually reminds me how in each of every one of our cells, DNA has to be correctly organized and maintained to be correctly regulated so that our genes can be read at the right levels and avoid the development of diseases like cancer. So let me explain why I'm thinking like this. So in every one of our cells, we have about 2 meters of DNA, which is taller than I am. And this needs to be organized. And to do this, DNA is wrapped around certain proteins. And just like in this photo of Castellers, the proteins would be the people, and then the DNA could be their belt that's wrapped around them and that serves a lot for stability. So on the string of DNA that's wrapping around our proteins, we have our genes. And in each one of our cells, we have about 20,000 genes. And each of these can be higher or lower expressed. And this expression needs to be tightly regulated to avoid the development of disease. We can often talk, for example, about open DNA, where the DNA has space for other proteins to come and read what's written on the DNA, and closed DNA, which is the opposite, where it's so tight together that nothing can be read, and therefore the genes in those zones can't be expressed. So open and closed DNA are very tightly regulated by diverse and specific mechanisms, and I'm going to talk to you about one today. But the loss of balance can cause cancers, just like the loss of balance in this tower could lead to everybody falling down and somebody could get hurt. In each of our cells, this specific balance exists, and the balance is what's going to differentiate, for example, a heart cell from a liver cell to a brain cell. And one of the mechanisms that control this genetics expression is using diverse proteins to wrap the DNA. So by having different proteins that differently wrap the DNA, you can have different gene expression. And for example, if you had all your Castellers in this tower as enchinatas, it would fall very quickly because you need a diversity there to create a strong tower. So my protein, macroH2A, wraps DNA very tightly around itself and causes lower expression because it's so tight that nothing can read what's written on the DNA. What's so interesting about this protein is that it has a long tail, which we always thought was useless and had no function. But we've actually shown for the first time that, in fact, it does have function in the expression of genes. And I'd like to explain to you why we think this is happening. So in each of our cells, everything is made up of charged molecules. For example, DNA is negatively charged and will avoid interacting with other negatively charged molecules. On the other hand, the tail of my protein is positively charged, and therefore we believe that those two are interacting very strongly with each other due to these opposing charges, and they stick together. So for example, if you had your Castellers and you put a big magnet on one and then an opposing magnet on the belt of another one, those two are going to get really close and they're going to start kind of like sticking together, and the tower is going to become more compacted, and so nothing can be read on the DNA in that tower. So this to us has really important and interesting outcomes in medicine. For example, if we could find a way of putting macroH2A in very specific places in our tower, we could switch off those genes that are causing, for example, cancers and reestablish balance so that nobody falls and gets hurt.